Okay, I'm going to solve the other heat exchanger question from your assignment. This is an open heat exchanger, meaning we have mixing that occurs. So if I was to draw it out as a diagram, what I have is some spot where mixing occurs, and I'm going to have at least a few inlets or outlets coming together. In this case, what I have is two inlets and then one outlet. And so if I just call them 1, 2, and 3, what I have is two flows that come in, they mix, their energy gets combined and balanced, and then I've got one flow that exits out. And so in this case, what I have is some steam and some water that comes in. So in my first pathway, what I have is first inlet, X is equal to 0.88 steam, and I have 2 kilograms per second. My other flow rate, what I have is 10 degree water, 10 degree C, and it is 28.9 kilograms per second. And so what happens is these guys come in, they mix, and out comes some fluid with some enthalpy 3 and some mass flow 3. And so if I look at how this works, what I have is a case where each fluid as it comes in has some mass flow associated with it, and it also has some energy level associated with it. It mixes with another fluid, and then what comes out is one final fluid that exits out. And so from an equation point of view, what I have is a couple of them. First of all, I've got this form. In a steady state situation, all of the fluid that comes in has to equal all of the fluid leaving. So I've got a balance of mass flow. I also have a balance of energy. So I don't have the case where my enthalpy plus my enthalpy is going to equal my enthalpy. This just doesn't happen. What I have is mass flow times enthalpy plus mass flow times enthalpy is equal to mass flow times enthalpy. So a certain quantity of fluid bringing a certain amount of energy with it, and I've got some balancing. So in order to solve this problem, what I'm going to have to do is figure out flow rates. For the most part I'm given. I'm going to have to find out enthalpies and then move on from there. So first of all, what I have is flow rate at the outlet is going to be my M3, and it is going to be equal to the two flows that are coming in. So I have 2 kilograms per second plus 28.9 kilograms per second. And what I end up with is 30.9 kilograms per second. And that's the fluid that's going to be leaving. Next thing, in order to find out from the energy's point of view, because I want to find out B, the enthalpy of the fluid at the outlet, what I'm going to need to do is figure out some enthalpies. So first one is going to be at 19,000 kPa. I have 0.88 quality steam. So in order to find that, I know if in the wet steam region, H is going to be equal to HF plus X times HFG. And if I go to my steam tables, so what I have is HF, HFG, and at 19,000, what I'm going to have is a couple of values. 1776.5 for HF and 688 for HFG. I'm going to put these guys away. So HF is going to be 1776.1 or 0.5 plus 0.88 times 688. And if I work out that calculation, what I get is 2381.94 kilojoules per kilogram. That would be my H1 value. H2 I can find by going to my steam tables again. This time, because it's a liquid, I'm going to go to my temperature table. So at 10 degrees Celsius, what I care about is my HF, 42.01. So my H2, so 42.01. Again, kilojoules per kilogram. So to find H3, what I'm going to do is I'm going to make use of this equation over here. So H3 is going to be M1H1 plus M2H2 all divided by M3. So my H3 is going to be equal to 2 times 2381.94 plus 28.9 times 42.01. All of that is divided by 30.9, and it gives me an H3 value of 193.46 kilojoules per kilogram. Now, if I'm trying to figure out what the final temperature is, again, I'm going to have to go back to my steam tables. So if I look at my temperature tables, what I can do is I can look for my HF value. Unfortunately, 193 does not match up to my tables. And so what I have is I'm somewhere in between 45 and 50. In order to find that, I'm going to interpolate. So what I have is the form temperature is going to be equal to your T1 plus your HX minus H1 over your H2 minus H1, all multiplied by T2 minus T1. Now I've written this out in this form. Just be careful, because when I have said HX, okay, that's easy enough. That's going to be my H3. Just careful, because my H1 value, as I've written it out, is not my value up here. My H2 value is not my H2 value up here. I'm just using this in terms of above and below in the steam tables. So when I write this out, my H1 is going to be the value that is related to my temperature 1. So when I say I've got my HX value, my H1 value, what that's going to relate to would be the H value at my T1. So if I go back to my tables, my T1 is going to be 45, meaning my H1 value in this case for this formula is going to be 188.45. My H2 value is going to relate to T2, which is going to relate to 209.33. If you add in your values correctly, so your different H values, your T2 is going to be 50, your T1 is going to be 45. What we should find is that you'll end up with a temperature 46.2 degrees Celsius. Oops. Okay, thanks.